I'm so glad you found your way here. Your consciousness is preparing for sleep right now. Dimming awareness. Releasing control. Getting ready to slip into a realm you visit every night, but rarely remember. You'll discover where your waking mind goes when darkness comes, and understand why consciousness never truly disappears, only transforms. Welcome to Psychology for Sleep. Now settle in. You're in your safe space while your brain quietly prepares for its nightly journey, readying itself to cross the threshold between wake and sleep. Allow yourself this moment of peace. We'll journey through 101 psychology facts about consciousness and sleep, from the exact moment awareness begins to fade, to the hidden realm where your mind processes the day, to the bridge between being awake and becoming someone who dreams. This thoughtful journey through consciousness builds bridges between searching minds. A soft like or sharing your thoughts creates a pathway for more seekers to discover this sanctuary of calm, one sleepy soul at a time. Your healing journey inspires ours. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now, we begin. Consciousness is the brain's ability to create your inner experience of existence. Every thought you think, every sensation you feel, every moment you're aware of being you. This is consciousness at work. Neuroscientists define it as the state of being awake and aware of your surroundings and yourself. It emerges from roughly 86 billion neurons. More connections in your head than stars in the Milky Way, firing in coordinated patterns. These neurons communicate through electrical signals and chemical messengers, creating the seamless experience of your thoughts, feelings, and perceptions. What makes consciousness remarkable is that it's both intensely personal, only you experience your version of it, and universal, something every human being shares right now. As you listen to these words, consciousness is allowing you to understand meaning, form mental images, and experience the quiet comfort of this moment. Your waking consciousness exists in layers, not as a single unified thing. The outermost layer is your immediate awareness, what you're thinking about right now, what you're seeing or hearing. Beneath that lies background awareness, processing sounds, sensations, and thoughts you're not actively focused on. Deeper still runs your subconscious, handling automatic functions like breathing and balance. Recent research from 2023 using advanced brain imaging shows these layers constantly communicate, with information flowing between them like water through connected pools. Your consciousness at any moment is actually a collaboration between these levels. Though you only notice the surface, the rest works in silence, shaping your experience without asking permission. Consciousness requires a minimum level of brain activity to exist. Like a candle needs a certain amount of oxygen to keep burning. Scientists can measure this electrical hum using electrodes placed gently on the scalp. When you're fully awake, reading this, thinking, planning, your brain produces fast, buzzing patterns called beta waves. oscillating at 13 to 30 cycles per second. If activity drops below a certain threshold, awareness dims or disappears entirely, like a light slowly fading. This threshold varies slightly between people, but it's surprisingly consistent. A reminder that consciousness is a biological process with measurable requirements. Right now, billions of neurons are maintaining that critical brightness, working together to keep you present in this moment. The thalamus acts as the gateway to consciousness. This walnut-sized structure deep in your brain filters incoming sensory information, deciding what reaches your conscious awareness and what stays beneath it. Every sight, sound, touch, taste, and smell passes through the thalamus first. When you're awake, the thalamus remains open, allowing information to flow freely to your cortex, where conscious processing happens. Studies published in late 2024 using optogenetics, a technique that controls neurons with light, confirmed that disrupting thalamic activity immediately dims consciousness. Even if the rest of the brain remains active, the thalamus is, in many ways, the gatekeeper between your inner world and outer reality, constantly deciding what deserves your attention. Consciousness has a speed limit. Experiments measuring reaction time show that it takes roughly 300 to 500 milliseconds, about half a second, for you to become consciously aware of something after it happens. Your brain detects events much faster, but the experience of knowing you detected them arrives with a slight delay. This creates an interesting paradox. You're always experiencing the past, never quite living in the true present moment. Yet this delay is necessary, allowing your brain time to integrate information from different senses, interpret meaning, and construct the coherent experience you call now. In a way, consciousness is always catching up to reality, smoothing out the rough edges of raw sensation into something that makes sense. The default mode network is consciousness at rest. When you're not focused on any specific task, when your mind wanders, daydreams, or reflects on yourself, a network of brain regions becomes active. First noticed in 2001 and studied extensively through 2024. This network includes the medial prefrontal cortex and posterior cingulate cortex. It's most active when you're doing nothing, letting thoughts drift freely. This resting state isn't empty consciousness. It's where you construct your sense of self, imagine future scenarios, and process social information. The default mode network is, in essence, the voice of your inner monologue, the part that narrates your existence when nothing else demands attention. Your sense of now spans roughly 2 to 3 seconds. Neuroscientist Ernst Poppel discovered that consciousness doesn't experience time as a continuous stream, but as a series of discrete moments, each lasting about 3 seconds. Your brain stitches these moments together so seamlessly that you perceive fluid continuity. This is why musicians can synchronize with each other, why conversation feels natural, and why you can catch a ball thrown toward you. Your consciousness lives in this 3-second window, constantly updating as each new moment replaces the last. The present you experience is actually a brief accumulation of immediate past, processed and presented as now. Time, as you consciously experience it, is a construction, elegant, continuous, but fundamentally created by the brain's need to organize reality into manageable chunks. Attention and consciousness are not the same thing, though they work closely together. You can be conscious without paying attention, like when you're vaguely aware of background music while reading. And attention can occur without full consciousness, as when you automatically duck from a thrown object before consciously realizing what happened. Recent studies from 2024 show attention acts like a spotlight, illuminating specific aspects of conscious experience while leaving others in shadow. You're always conscious of more than you're attending to. The feel of your clothes, the hum of ambient sound, the pressure where your body touches the bed. Attention selects from this wider field of consciousness, bringing certain elements into focus while others fade into comfortable obscurity. Consciousness emerges from integration, not from any single brain region. Imagine an orchestra. No single musician creates the symphony. The integrated information theory, developed by neuroscientist Giulio Tononi and refined through 2024, proposes that consciousness arises when information is both differentiated and unified across the brain, like different instruments playing distinct parts that blend into one coherent piece. Many separate regions must be active, each processing different aspects of experience: visual, auditory, emotional, spatial, and these must combine into a single, coherent whole. This is why consciousness disappears during deep sleep or anesthesia, not because brain activity stops, but because integration breaks down. Different regions begin working independently, no longer communicating in the coordinated way that creates unified awareness. Consciousness, in this view, is less about what the brain does and more about how it does it. Through connection, integration, synthesis. Your brain uses roughly 20% of your body's energy, despite being only 2% of your body weight. Most of this energy supports consciousness, maintaining the electrical gradients that allow neurons to fire, synthesizing neurotransmitters, and coordinating the complex networks that create awareness. Being conscious is metabolically expensive. This is one reason sleep is necessary. Your brain cannot maintain this level of activity indefinitely. As you move towards sleep, energy demands decrease, allowing the brain to shift from maintaining consciousness to performing maintenance, clearing waste, consolidating memories, repairing cellular damage. So even now, as your awareness gently fades, your brain is beginning to conserve energy, preparing for the restorative work that happens when consciousness finally lets go. Conscious awareness has limits, famously described as the magic number 7. Psychologist George Miller found in the 1950s that humans can hold roughly 7 items in conscious awareness at once, give or take 2. More recent research from 2023 suggests the true limit is closer to 4 items. Try to hold more, and older items slip away, forgotten as new ones take their place. This limitation is why consciousness feels so selective, so narrow compared to everything happening around and within you. You can only attend to a few things at once. Everything else, the vast majority of your experience, remains outside awareness, processed but not consciously known. It's a reminder that what you're aware of is a tiny fraction of what you're actually experiencing. Conscious perception involves both bottom-up and top-down processing. When you see your coffee cup in the morning, you don't just see brown liquid in a ceramic container. You instantly recognize coffee cup because your brain predicts what's there based on past experience. You might even see steam rising when it's actually cold, or not notice a crack in the side because your brain expects wholeness. Bottom-up processing starts with raw sensory input. Light hitting your eyes, sound waves reaching your ears. Top-down processing works in reverse. Your expectations, memories, and knowledge shape what you consciously perceive. Studies from 2024 using functional MRI show that top-down predictions are just as important as bottom-up sensation in creating conscious awareness. Your consciousness is always a collaboration between what's actually there and what your brain expects to be there, blending reality with prediction into a seamless whole. The feeling of free will, the sense that you consciously choose your actions, may be more complex than it seems. Neuroscientist Benjamin Libet discovered in the 1980s that brain activity patterns called readiness potentials appear roughly 500 milliseconds before conscious awareness of the intention to move. This finding initially suggested that unconscious processes might begin decisions before awareness, though Libet himself noted that consciousness could still veto actions in the final 200 milliseconds. Recent research reveals the readiness potential may reflect neural readiness or background noise rather than decisions themselves. The debate continues among scientists about exactly when and how conscious intention relates to brain activity. This curious question about the relationship between neural processes and subjective experience continues to fascinate researchers, revealing how mysterious the connection between brain activity and conscious choice remains. Some things about consciousness, it seems, resist simple explanations. Language deeply shapes conscious thought. The words you know influence what you can consciously think about. Studies of people who speak multiple languages show that consciousness subtly shifts depending on which language is active. Your inner monologue, the voice narrating your thoughts, relies on language structures learned in childhood. Experiments from 2023 with individuals who lost language ability due to brain injury revealed that conscious thought becomes more visual, more emotional, less structured without words to organize it. Language gives consciousness a tool for precision, for abstract reasoning, for planning the future. Without it, awareness still exists, but it flows differently, less constrained by categories, more immediate and sensory. Conscious awareness can be trained and modified. Meditation practitioners who've spent thousands of hours in practice show measurable changes in brain activity during consciousness. Long-term meditators can sustain focused attention longer, reduce default mode network activity at will, and report altered states of consciousness that non-meditators rarely experience. Research from 2024 using advanced EEG analysis shows meditation increases gamma wave activity, the fastest brain waves, associated with heightened awareness and mental clarity. These changes suggest consciousness isn't fixed. It's malleable, capable of being shaped through practice. The way you experience awareness right now isn't the only way. With time and effort, consciousness can become broader, more stable, more vividly awake. Or, as you're discovering now, it can gently dim towards sleep. Consciousness exists on a spectrum, not as an on-off switch. Between fully awake and completely unconscious lie many gradations: drowsiness, light sleep, deep sleep, dreaming, anesthesia, coma. Each represents a different level and type of awareness. The Glasgow Coma Scale, used in medicine, quantifies consciousness from 3, no response, to 15, fully alert. But even within awake, consciousness varies. Morning alertness differs from afternoon fatigue. Focused work differs from relaxed daydreaming. Every moment, your level of consciousness fluctuates subtly, rising and falling like a tide. Right now, you're likely somewhere between alert waking and drowsy relaxation, a comfortable middle ground where thoughts flow easily. But focus softens, and the pull towards sleep grows stronger with each passing fact. The prefrontal cortex plays a crucial role in higher consciousness, self-awareness, planning, abstract reasoning, moral judgment. This region, located just behind your forehead, is disproportionately developed in humans compared to other animals. Damage to the prefrontal cortex doesn't eliminate consciousness, but it changes its character. Impulse control weakens. Long-term planning becomes difficult, and the sense of self may fragment. During sleep, prefrontal activity decreases significantly, which is why dreams lack logical coherence and critical judgment. You accept impossible scenarios in dreams because the part of consciousness that questions and analyzes has gone quiet. As you drift towards sleep, prefrontal regions are among the first to reduce activity, allowing awareness to soften, becoming more accepting, less analytical, more willing to surrender to rest. Consciousness creates the experience of subjective time, separate from clock time. When you're engaged and enjoying yourself, time seems to fly. When you're bored or in pain, it drags. This subjective time is a creation of consciousness, shaped by attention, emotion, and memory. Studies from 2024 using time perception tests show that consciousness speeds up or slows down its internal clock, depending on circumstances. You've probably noticed this. A day of new experiences feels longer in memory than a day of routine. Consciousness doesn't passively receive time. It constructs temporal experience, stretching and compressing the flow of moments according to psychological needs. In sleep, this sense of time disappears almost entirely. Hours can pass in what feels like seconds, or no time at all. Mirror neurons give consciousness the ability to understand others. These specialized neurons fire both when you perform an action and when you observe someone else performing it. Discovered in the 1990s and confirmed through extensive research including 2024 studies, mirror neurons allow you to simulate others' experiences in your own brain. When you see someone smile, mirror neurons create a faint echo of smiling in your motor cortex. This is the neural basis of empathy. Your consciousness can briefly inhabit another person's perspective. It's also why yawning is contagious, why watching someone in pain makes you wince, why stories can move you emotionally even though you know they're fiction. Consciousness is inherently social, shaped by and connected to the conscious experiences of others. Your conscious mind can only process about 40 to 50 bits of information per second. Even though your sensory systems receive roughly 11 million bits per second, imagine trying to drink from a fire hose through a drinking straw. That's what your brain does with incoming information. This enormous gap means consciousness is highly selective. A tiny fraction of available information reaches awareness, Your brain filters ruthlessly, discarding the irrelevant, highlighting the important, constructing a simplified version of reality that's manageable. This filtering happens unconsciously, before you're aware anything was filtered. So the world you consciously experience isn't the world as it is. It's a carefully curated version, edited for relevance and coherence. Most of reality passes through you unnoticed, unseen, unfelt, including, right now, the subtle shift as your brain begins preparing for sleep. Consciousness has a negativity bias. You're more likely to notice and remember negative information than positive. This bias evolved because threats required immediate attention for survival. A rustling bush might be a predator. Better to be hyper-aware of danger than relaxed and vulnerable. Modern research from 2024 confirms this bias persists even in safe environments. Negative news captures attention more than positive news. Criticism stings more than praise soothes. And anxious thoughts loop more persistently than peaceful ones. This negativity bias can make consciousness feel heavy, burdened by worry and stress. But awareness of the bias can soften its grip. Knowing your mind naturally gravitates toward the negative, you can gently redirect attention toward calm, toward comfort, toward the quiet settling that leads to sleep. The sense of self is a construction of consciousness, not a fixed entity. Neuroscientist Thomas Metzinger describes the self as a transparent model. Your brain creates a representation of you, then presents it as if it's the real thing. This is why you feel like a unified, continuous person even though your body, thoughts, and circumstances constantly change. The self-model is built from body awareness, memories, social roles, and internal narratives. It feels solid and real, but it's actually fluid, updating constantly based on new information. Some meditative traditions aim to see through this construction. In deep sleep, the self-model dims significantly. The narrative you quiets, though something of identity persists beneath awareness, ready to reconstruct itself upon waking. Consciousness can be disrupted by very simple manipulations. Transcranial magnetic stimulation, applying magnetic fields to specific brain regions, can temporarily eliminate awareness of certain types of information. Flash a word on a screen while disrupting visual cortex processing, and you won't consciously see it, even though your eyes registered it. Similarly, binocular rivalry experiments show that consciousness chooses between conflicting sensory inputs. Show different images to each eye, and you'll consciously see only one at a time, alternating back and forth. These simple disruptions reveal how fragile conscious awareness is, how easily it can be interrupted, redirected, or fooled. Even now, as fatigue accumulates, your consciousness becomes more vulnerable to disruption, more willing to let go of waking awareness and slip into sleep's gentler state. Emotions, color consciousness, shaping how you experience every moment. When you're happy, the world seems brighter. When you're sad, it feels heavier. This isn't metaphorical. Emotional states literally change how your brain processes sensory information. A 2024 study using functional MRI showed that emotional context alters activity in primary sensory cortices, meaning emotion reaches all the way down to basic perception. You don't first perceive neutrally, then add Emotion. Emotion is woven into perception from the start. This is why music can seem more beautiful when you're in love. Why food tastes better when you're relaxed. Why the same room feels different depending on your mood. Consciousness is never purely cognitive or purely emotional. It's always both. Thoughts and feelings blending into the unified experience of being alive. Consciousness requires constant calibration between prediction and reality. Your brain generates predictions about what will happen next, then compares those predictions to actual sensory input. When they match, experience feels smooth and unremarkable. When they don't match, you experience surprise. Consciousness, highlighting the discrepancy for attention and learning. This predictive processing happens automatically, beneath awareness. But it shapes conscious experience profoundly. A 2024 review of neuroscience research concluded that consciousness might be best understood as controlled hallucination. Your brain guessing what's there, using sensory data to refine those guesses. You're never directly experiencing reality. You're experiencing your brain's best model of reality, constantly updated but never perfect. And now, as you approach sleep, your brain's predictions begin to loosen, allowing consciousness to drift, becoming less tethered to the external world. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell working in silence. Trillions of organisms functioning quietly, heart beating, lungs breathing, neurons firing, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-regulating, alive with invisible processes. Your consciousness rests on this foundation of automatic life. Now we continue. The journey into sleep begins before you notice it. Even while you feel awake, your brain starts shifting into sleep mode. Research from 2024 using continuous EEG monitoring shows that microsleeps, brief moments of sleep lasting 1 to 5 seconds, begin occurring during drowsiness. Your eyes might still be open, you might still feel conscious, but patches of your brain briefly go offline. These microsleeps become more frequent as sleep pressure builds. You probably won't notice them. Consciousness smooths over the gaps, but they're there. Tiny previews of the sleep to come. Evidence that the boundary between wake and sleep is blurrier than it seems. Sleep pressure accumulates through a molecule called adenosine. Throughout the day, as your neurons work, they break down ATP, the energy molecule, into adenosine. Adenosine builds up in your brain, binding to receptors and creating the sensation of tiredness. The longer you've been awake, the more adenosine accumulates, and the stronger sleep pressure becomes. Caffeine works by blocking adenosine receptors, temporarily masking sleepiness without actually reducing the underlying pressure. When caffeine wears off, all that accumulated adenosine floods back, often creating a sudden crash. Right now, unless you've had recent caffeine, adenosine levels are high, pressing gently on consciousness, making alertness harder to maintain and sleep increasingly attractive. Your thalamus, the gateway to consciousness, is the first region to change during sleep onset. As adenosine and other sleep-promoting chemicals increase, the thalamus begins filtering more aggressively. Instead of allowing all sensory information through to consciousness, it starts blocking routine inputs, background noise, minor tactile sensations, ambient light. This is why external sounds seem to fade as you drift toward sleep. They're still reaching your ears, but the thalamus prevents them from reaching conscious awareness. Research published in late 2024 shows this thalamic gating is highly selective. Threatening sounds like a baby's cry or a smoke alarm can still break through, while neutral sounds get blocked. Consciousness doesn't disappear all at once. It withdraws selectively, maintaining vigilance for danger while releasing attention to the irrelevant. The transition from wake to sleep involves a specific brainwave shift. When you're awake and relaxed, your brain produces alpha waves, rhythmic oscillations at 8 to 12 cycles per second. Like the gentle rhythm of ocean waves, as drowsiness deepens, alpha waves give way to theta waves, slower oscillations at 4 to 8 cycles per second. This theta state is the borderland between wake and sleep, where consciousness becomes looser, more dreamlike. Thoughts begin fragmenting, logic weakens, and hypnagogic hallucinations, brief, vivid images or sounds, sometimes occur. You might experience the sensation of falling, or hear your name called, or see fleeting patterns behind closed eyes. These are neither fully waking nor sleeping experiences, but something in between, proof that consciousness doesn't switch off. It transforms. Hypnagogic hallucinations affect roughly 70% of people at some point. These strange sensory experiences during sleep onset can be visual, auditory, or tactile. You might see geometric patterns, faces, landscapes, hear music, voices, or meaningless sounds, feel like you're floating or falling. Neuroscientists believe hypnagogic hallucinations occur because the thalamus is partially gated. Some sensory processing regions remain active, while others shut down, creating incomplete perceptions that consciousness interprets as real. They're harmless, usually brief, and often forgotten immediately, but they reveal something important. Consciousness during sleep onset is confused, trying to make sense of fragmentary neural activity, no longer sure what's external and what's internal. The boundary between imagination and perception dissolves. Sleep paralysis sometimes accompanies the transition into sleep. Normally, motor neurons shut down during REM sleep to prevent you from acting out dreams. Occasionally, this paralysis activates early, during sleep onset, leaving you conscious but unable to move. It can feel concerning. You're aware. Your eyes might be open, but your body won't respond. Sleep paralysis affects roughly 8% of people at least once. Understanding the mechanism helps reduce worry. It's a timing mismatch. Muscles shutting down before consciousness fully departs. It typically lasts only seconds to minutes and resolves on its own. If you've experienced it, know it's not harmful. Just consciousness caught between states, briefly aware of the body's protective paralysis that normally goes unnoticed. The exact moment you fall asleep is impossible to identify precisely. If someone asks, "When did you fall asleep?" you can't answer accurately because consciousness doesn't experience its own cessation. You're awake, processing that you're awake. And then, nothing. the transition leaves no memory. Sleep researchers define sleep onset as the first 30-second epoch where theta waves dominate and responsiveness to stimuli decreases. But subjectively, there's no clear boundary. Consciousness fades gradually, like twilight deepening into night, until at some unmarked moment, awareness slips away entirely. You never witness the exact instant you fall asleep. It happens in the gap between the last thing you remember and the first thing you don't. Dreams can begin during sleep onset, not just in REM sleep. These early dreams, called hypnagogic dreams, tend to be brief, fragmentary, and unusual. You might dream of conversation snippets, strange visual imagery, or absurd scenarios that make no sense upon waking. Research from 2024 using sleep lab awakening protocols shows that roughly 50% of people report some dream content if woken during the transition to sleep. These early dreams differ from REM dreams. They're shorter, less narrative, more like random thoughts given sensory form. They occur because the brain's language and sensory regions remain partially active while logical. Executive regions quiet. Consciousness, no longer constrained by waking logic, begins creating without editing, dreaming without yet being fully asleep. Your sense of time collapses during sleep onset. Minutes can feel like seconds, or vice versa. When people are woken shortly after falling asleep and asked to estimate how long they've been sleeping, answers vary widely. Some guess minutes when hours have passed. Others guess hours when only minutes have passed. This temporal confusion occurs because the brain regions responsible for tracking time, particularly the prefrontal cortex, reduce activity during sleep onset. Consciousness loses its anchor in clock time, drifting into a timeless state. Right now, you might feel like you've been listening for a long time, or maybe not long at all. The sense of duration becomes unreliable as sleep approaches, and that's perfectly normal. Time, as a conscious construct, requires effort to maintain. When consciousness relaxes, time dissolves. The sleeping brain begins ignoring your name during deep drowsiness, but not completely. Studies from 2023 using auditory stimuli during sleep onset found that hearing your own name still produces a measurable brain response, even when you don't consciously hear it. The auditory cortex and some deeper structures react, but the information doesn't reach full awareness. This selective responsiveness is part of consciousness's gradual withdrawal, prioritizing personal relevance while filtering out neutral information. A smoke alarm will wake you. A distant car horn won't. Your name still matters. Even as consciousness fades, the brain maintains a minimal surveillance system, monitoring for significance, ready to restore full awareness if something important enough demands it. Body temperature drops as you fall asleep, signaling the brain that it's time to rest. Core temperature decreases by roughly 1 degree Fahrenheit during the night. This cooling is controlled by the hypothalamus, which regulates both temperature and sleep-wake cycles. Warm environments can delay sleep onset because they interfere with this natural cooling. Conversely, cooling the body through a cool room or breathable bedding facilitates faster sleep onset. The temperature drop isn't just a side effect of sleep, it's part of the mechanism triggering it. As your body cools now, as warmth radiates from your skin into the surrounding air, Your brain interprets this as permission to let go, to stop maintaining vigilant consciousness, to surrender to sleep's restoration. Muscle tension releases progressively during sleep onset. The body shifts from the slight tension of waking posture to the complete relaxation of sleep. This release often begins in the facial muscles, jaw, eyes, forehead, then spreads to the shoulders, arms, torso, and legs. Sometimes this release triggers a hypnic jerk, a sudden muscle spasm that can briefly wake you. Hypnic jerks affect roughly 70% of people occasionally. Scientists aren't entirely sure why they occur, but one theory suggests that as muscle tone drops, the brain misinterprets the relaxation as falling, triggering a protective reflex. If you experience a hypnic jerk tonight, it's just your nervous system recalibrating, adjusting to the transition between active waking control and passive sleeping release. Eye movements slow and roll during sleep onset. When you're awake, your eyes make rapid, targeted movements called saccades. As drowsiness increases, eye movements become slower and more rolling. A pattern called slow rolling eye movements, or SEMs. These SEMs are one of the clinical markers sleep researchers use to identify sleep onset. You can't consciously control them well. They happen automatically as the brain's oculomotor control relaxes. If your eyes are closed now, you might notice them wanting to roll upward or drift side to side. That gentle rolling is consciousness releasing its grip on precise visual control, allowing the eyes to rest, to move without purpose, to follow the brain's internal rhythms rather than external targets. Thoughts become looser and less logical during sleep onset. The prefrontal cortex, responsible for executive function and logical reasoning, decreases activity while other regions remain active. This creates a mental state where ideas flow more freely. Unconstrained by critical evaluation, you might think about unrelated topics in rapid succession, accept contradictory ideas without questioning, or find profound meaning in trivial observations. This loosening can feel pleasant, a relief from the rigidity of waking thought. Creative people sometimes value this state, reporting that useful ideas emerge during drowsiness when waking logic would have dismissed them. Consciousness, freed from its usual constraints, wanders through possibility, exploring without judgment, thinking without needing answers. The default mode network, active during waking rest, changes its activity as sleep approaches. During normal waking rest, the default mode network coordinates autobiographical memory, self-reflection, and future planning. But during sleep onset, connectivity between regions within this network begins decreasing. The narrative you constructed by the default mode network starts fragmenting. Memories surface without context. Future scenarios appear without reason, and the sense of self becomes less stable. Research from 2024 using fMRI during sleep onset shows this fragmentation correlates with the subjective sense of losing awareness. As the default mode network disconnects, the coherent self-narrative that defines waking consciousness dissolves, making way for the discontinuous, fragmented experience of early sleep. You're still here with me. Thoughts still flickering like candlelight. Just notice. Don't judge. Just notice where your mind is right now. we're exploring consciousness itself. The very thing doing the exploring. Strange, beautiful, and perfectly calm. Let's drift onward together. Consciousness doesn't disappear during sleep. It transforms. This is the central insight from decades of sleep research. When you sleep, awareness doesn't cease entirely. It changes character, becoming different kinds of consciousness appropriate to different sleep stages. During light sleep, a dim awareness persists. You might shift position, pull up covers, or scratch an itch without fully waking. During deep sleep, consciousness recedes further, but the brain remains responsive to certain stimuli. During REM sleep, consciousness returns in the form of vivid dreaming. Sleep is not unconsciousness, it's altered consciousness, serving functions that waking awareness cannot. The question isn't where does consciousness go, but rather what does consciousness become? During N1 sleep, the lightest stage, consciousness hovers in a twilight state. N1 lasts roughly 5 to 10 minutes at sleep onset and occupies about 5% of total sleep time. Brainwaves shift from alpha to theta. The thalamus partially closes the sensory gate, but awareness hasn't fully withdrawn. If woken during N1, most people report they were just drifting, not quite asleep but no longer awake. Consciousness here is minimal, fragmented, dipping in and out. External sounds may blend with internal thoughts. Time sense is unreliable. The sense of self flickers. N1 is the vestibule of sleep, where consciousness lingers briefly before proceeding deeper, reluctant to fully let go, but too tired to maintain full vigilance. N2 sleep marks consciousness's withdrawal from the external world. During N2, which comprises roughly 45 to 55% of total sleep, the brain produces sleep spindles and K complexes, distinctive patterns visible on EEG, like the brain's signature written in electrical ink. Sleep spindles are brief bursts of rapid brain waves lasting a second or two, occurring dozens of times per hour. K complexes are large, slow waves that may help filter out external stimuli. Together, these patterns suggest the brain is actively protecting sleep, blocking out disturbances that might restore waking consciousness. If you're woken from N2, you'll usually feel more disoriented than from N1. Awareness taking longer to return. Consciousness here has receded significantly, though not entirely. It's still there, but quiet, dim, far from the surface. During deep sleep, N3, or slow wave sleep, consciousness reaches its lowest ebb. The brain produces delta waves, slow oscillations at 1 to 4 cycles per second. These waves indicate synchronized firing across large regions of cortex, a pattern incompatible with the differentiated activity that creates waking consciousness. People woken from deep sleep often feel confused, disoriented, unsure where they are or what's happening. Awareness takes minutes to fully return. Yet even in deep sleep, the brain isn't inactive. It's performing maintenance, consolidating memories, clearing metabolic waste, repairing tissues. Consciousness as you know it is gone, but biological intelligence remains active, doing work that only happens when awareness steps aside. This is sleep's deepest purpose. Restoration that requires consciousness's absence. The glymphatic system, discovered in 2012 and confirmed in human studies through 2024, clears waste from the brain during sleep. Throughout waking consciousness, neurons produce metabolic byproducts, including beta amyloid and tau proteins, which accumulate in spaces between cells. During sleep, particularly deep sleep, brain cells physically shrink, increasing interstitial space by roughly 60%. Cerebrospinal fluid then flows through these widened channels, flushing out waste products. This cleaning process requires consciousness to diminish, because the energy and space needed for awareness conflicts with the energy and space needed for waste clearance. Your brain cannot simultaneously maintain full consciousness and perform deep cleaning. Sleep makes consciousness impossible, but in doing so, keeps your brain healthy for tomorrow's awareness. REM sleep brings consciousness back in a radically different form. Dreaming. REM stands for rapid eye movement. The distinctive eye movements, visible even through closed lids during this stage. REM sleep comprises roughly 20 to 25% of total sleep and occurs in cycles throughout the night, with longer REM periods toward morning. During REM, brain activity resembles waking patterns. The cortex is highly active, metabolism increases, and neurotransmitter balance shifts. But you're deeply asleep, paralyzed to prevent acting out dreams. Consciousness during REM is vivid, immersive, often unusual. You experience sights, sounds, emotions, and narratives, accepting impossible scenarios without question. It's consciousness unmoored from reality, free to create worlds without constraint. Dreaming consciousness lacks critical thinking because the prefrontal cortex remains relatively inactive during REM sleep. The dorsolateral prefrontal cortex, responsible for logic, planning, and reality testing, shows reduced activity while sensory and emotional regions activate strongly. This explains why dreams feel real while you're dreaming. The part of consciousness that questions improbability is offline. You fly, talk to the dead, watch events from impossible perspectives, and accept it all as normal, only upon waking. When the prefrontal cortex reactivates, do you recognize how strange the dream was? Dream consciousness is emotional, visual, narrative-driven, but not analytical. It's consciousness optimized for processing emotion and memory, not for navigating physical reality. Not all sleep includes dreams you can remember. REM dreams are typically the most vivid and memorable, but dreaming also occurs during non-REM sleep. Studies waking people during N2 and N3 sleep find that roughly 50 to 70% report some mental activity, thoughts, images, or vague impressions. These non-REM dreams tend to be less vivid, less narrative, more thought-like than REM dreams. You might think about work, replay recent conversations, or experience vague anxiety without clear imagery. Most non-REM dreams are forgotten immediately upon waking. This suggests consciousness during sleep exists on a spectrum, from the near absence of deep sleep, through the dim thought-like awareness of light sleep, to the vivid immersion of REM dreaming. Dream content reflects emotional processing more than factual memory consolidation. Research analyzing thousands of dream reports found that dreams incorporate emotions more frequently than specific factual details from waking life. You might dream about feeling anxious, but in a scenario nothing like what actually worried you during the day. Neuroscientist Matthew Walker's work, published through 2024, suggests REM sleep helps process emotional experiences, stripping away the intensity while preserving the memory. Dreams create safe simulations where you can experience fear, joy, anger, or sadness without real consequences. Consciousness during REM isn't passive replay. It's active emotional integration, blending memory with imagination to help you metabolize feelings that waking life provoked. Consciousness during sleep might serve creative problem solving. Famous insights have occurred in dreams. Kekulé's discovery of benzene's structure, Mendeleev's periodic table, Paul McCartney's melody for Yesterday. While these may be anecdotal, controlled studies show sleep, particularly REM sleep, enhances creative thinking. One 2023 experiment gave participants puzzles before sleep, then tested them after. Those who reached REM sleep solved more puzzles creatively than those who didn't sleep or didn't reach REM. Sleep consciousness, freed from logical constraints, makes novel connections between distant concepts. When waking, consciousness releases control. Sleeping consciousness explores possibilities, playing with ideas in ways that rigid waking thought cannot. Creativity requires letting go, and sleep provides the ultimate letting go. Breathe slowly now, and let each breath guide you to realize time is yours, a separate stream that only you are living. While the vast universe continues its motion, this second you're breathing, listening, is unique to you. There's no past you can return to, no future you can grasp. Only this moment, softly fading as sleep approaches. Cherish the present, knowing that consciousness exists only now, always now, even as now dissolves into sleep, and we continue drifting. Sleep consolidates memories, transferring them from temporary storage to long-term networks. During waking consciousness, experiences register in the hippocampus, a temporary holding area. During sleep, particularly during N2 and N3 stages, the hippocampus replays these experiences in compressed form, sending them to the cortex for permanent storage. Studies using intracranial electrodes in 2024 captured this replay happening in real time. Memories consolidate better after sleep than during equal time awake. This process happens without conscious effort or awareness. You don't decide which memories to consolidate. Sleep handles it automatically. Consciousness during sleep may be minimal, but the unconscious machinery of memory works tirelessly, organizing the day's experiences, deciding what to keep, what to connect, what to discard into forgetting. Sleep strengthens motor skills and procedural learning through a process called offline learning. When you practice playing piano, typing, or any physical skill, improvement happens not just during practice, but during subsequent sleep. Studies tracking skill performance before and after sleep consistently show improvement even without additional practice. The motor cortex and cerebellum replay movement patterns during sleep, refining neural pathways. Athletes know this intuitively. Rest is essential for skill development. Consciousness isn't required for this learning. In fact, conscious effort might interfere. The sleeping brain optimizes movements without awareness, smoothing out inefficiencies, strengthening successful patterns. When you wake, your hands remember better than they did before you slept. Sleep teaches the body what the mind couldn't perfect while awake. Dreams may rehearse threatening scenarios, preparing you for waking challenges. The threat simulation theory, proposed by psychologist Antti Revonsuo, suggests that dreaming evolved to practice responses to danger. While modern life rarely includes predators or mortal threats, dreams still frequently involve anxiety-provoking situations. Being chased, failing exams, losing loved ones. These scenarios activate fear and stress responses in a safe context. Research from 2023 found that people who experienced nightmares before stressful events performed better during those events. Consciousness during dreaming provides a training ground for emotions, letting you experience fear, react to it, and survive, all without real danger. It's emotional rehearsal, preparing waking consciousness for difficulties it might face. Sleep helps regulate emotional reactivity, preventing waking consciousness from becoming overwhelmed. Studies show sleep-deprived people experience stronger negative emotional reactions to minor stressors. After good sleep, the same stressors feel manageable. This regulation happens through REM sleep, which appears to process and diffuse emotional intensity. Brain imaging studies show the amygdala, the fear and emotion center, becomes hyperactive after sleep deprivation, but remains balanced after adequate sleep. Dreams may be part of this process, allowing you to experience difficult emotions in a safe, controlled context. By morning, yesterday's frustrations feel smaller. Sleep hasn't erased the memory, but it's stripped away some emotional charge. Consciousness during sleep does repair work that waking consciousness cannot. The sleeping brain continues monitoring the environment for threats, maintaining a minimal sentinel awareness. This is why certain sounds, a baby crying, your name, a smoke alarm, can wake you even from deep sleep, while neutral sounds don't. Research from 2024 using fMRI during sleep showed the auditory cortex and amygdala respond to personally relevant or threatening sounds even when consciousness is minimal. This protective awareness operates beneath the threshold of conscious experience. You're not aware of being aware, but some part of your brain stays vigilant. Sleep is not complete vulnerability. It's selective rest, where most of consciousness withdraws, but a guardian remains, ready to restore full awareness if danger appears. You can let go safely. Knowing this sentinel watches, sleep deprivation degrades consciousness itself. After 24 hours without sleep, cognitive performance declines sharply. Reaction time slows, attention wanders, and errors increase. After longer deprivation, microsleeps intrude involuntarily, and hallucinations may occur. After 11 days without sleep, the longest documented period, awareness became fragmented and unreliable, showing how deeply consciousness depends on rest. Sleep isn't optional. Consciousness requires it. Without sleep, awareness becomes scattered, uncertain, eventually difficult to maintain. This demonstrates that consciousness is not something you can sustain through will alone. It depends on biological processes that restore themselves only during sleep. The very awareness allowing you to think about consciousness needs sleep to continue existing tomorrow. Rest is not weakness, it's maintenance of the mind. Some people experience lucid dreaming. Where consciousness becomes aware, it's dreaming. Roughly 55% of people report having at least one lucid dream in their lifetime. During lucid dreaming, you recognize you're asleep while remaining asleep, sometimes gaining control over dream content. Brain imaging shows that lucid dreaming activates frontal regions normally inactive during REM sleep. It's a hybrid state. Part dreaming, part waking awareness. Consciousness, operating in a realm that shouldn't support it. Some people train themselves to lucid dream regularly. This suggests consciousness is more flexible than we assume, capable of existing in altered states that blend different modes of awareness. Even in sleep, consciousness can sometimes wake up within itself, becoming aware of its own dreaming nature. The sleeping brain reorganizes information, finding hidden connections. One study gave people problems that required insight to solve, then tested them after sleep or equal time awake. The sleep group solved significantly more problems. Sleep helps see relationships that waking consciousness missed. This reorganization likely happens during REM sleep when the brain activates broadly, linking distant concepts. Thomas Edison famously took brief naps while working on problems, believing sleep provided insights. Modern research suggests he was right. Consciousness during sleep doesn't think logically, but it thinks associatively, making connections waking logic wouldn't make. Sometimes the answer arrives not through effort, but through surrender. Not through thinking harder, but through sleeping deeply. Sleep may help forget as much as it helps remember. Not all experiences need preservation. Some should be discarded. Sleep appears to filter memories, strengthening important ones while letting trivial ones fade. Research from 2024 showed that memories tagged as irrelevant before sleep were more likely to be forgotten than those tagged as important. This forgetting isn't failure, it's efficiency. Consciousness can't hold everything. The brain must prioritize, keeping what matters and releasing what doesn't. Sleep does this triage automatically. When you wake, unable to remember yesterday's minor details, that's not decay, it's curation. Your sleeping brain decided those details didn't warrant storage, freeing space for information that does. Forgetting is as important as remembering. Dreams incorporate recent experiences in unexpected ways, a phenomenon called dream lag effect. Experiences from 1 to 2 days ago appear in dreams more often than very recent or very distant memories. Researchers don't fully understand why, but it suggests sleep consciousness integrates new information with existing knowledge over several sleep cycles. A conversation from yesterday might appear in tonight's dream, blended with childhood memories and fictional scenarios. Sleep consciousness doesn't replay experiences linearly. It remixes them, creating novel combinations. This remixing might help integrate new information into your existing understanding of the world, connecting new to old, making sense of change by linking it to what you already know. The autonomic nervous system shifts during sleep, affecting consciousness indirectly. During deep sleep, parasympathetic activity increases. Heart rate slows. Blood pressure drops. Digestion becomes more active. This physiological calming supports the brain's restorative work. During REM sleep, sympathetic activity increases. Heart rate becomes variable. Breathing irregular. And the body physiologically resembles waking arousal despite being deeply asleep. These shifts influence consciousness. Deep sleep's calm physiology supports minimal awareness. REM sleep's activated physiology supports vivid dreaming. Your consciousness is embodied, shaped by the state of your body. As your heart slows now, as your breathing deepens, consciousness receives signals. It's time to rest, to let go, to allow awareness to fade. Children's sleep differs from adult sleep in ways that support development. Children spend more time in REM and deep sleep than adults. Newborns spend roughly 50% of sleep in REM, compared to 20% in adults. This extra REM sleep supports rapid brain development, forming neural connections, consolidating learning, processing experiences. As we age, sleep architecture changes. Less deep sleep, less REM, more fragmented sleep. Consciousness during sleep serves different purposes across the lifespan. In childhood, it supports growth. In adulthood, it supports maintenance. In older age, despite less restorative sleep, the brain adapts. Sleep consciousness is not static. It evolves with you, changing as your brain's needs change. Certain medications and substances alter sleep consciousness dramatically. Alcohol, for example, increases deep sleep early in the night, but suppresses REM sleep, reducing dreams. Sleeping pills may help you fall asleep, but often reduce sleep quality by suppressing deeper stages. Antidepressants can dramatically increase or decrease REM sleep depending on type. Marijuana affects dream recall, often reducing it. These chemical interventions reveal that consciousness during sleep is neurochemically mediated. Different neurotransmitters, serotonin, dopamine, acetylcholine, GABA, create different states of sleep consciousness. Altering neurochemistry alters awareness. Even in sleep, your sleeping mind is sensitive to what you consume, shaped by substances just as waking consciousness is. Sleep disorders reveal how fragile sleep consciousness is. In narcolepsy, REM sleep intrudes into waking. People experience dream-like hallucinations, muscle paralysis, or sudden sleep attacks. In sleepwalking, motor control activates during sleep while consciousness remains mostly absent. People perform complex behaviors with no memory afterward. In REM behavior disorder, the normal paralysis fails, and people act out dreams, sometimes energetically. These disorders show that sleep is a complex coordination of many systems. When coordination fails, consciousness exists in inappropriate states. Awake when it should sleep. Mobile when it should be paralyzed. Dreaming when it should be alert. Most people's sleep consciousness operates smoothly, invisibly orchestrating the transition between wake and sleep without error. The suprachiasmatic nucleus, your brain's master clock, orchestrates the timing of sleep and wakefulness. Located in the hypothalamus, this tiny region responds to light detected by the eyes, maintaining your circadian rhythm. It signals the pineal gland to release melatonin at night, promoting sleep. It coordinates body temperature, hormone release, and arousal systems. Without it, sleep becomes chaotic, occurring randomly throughout the day and night. Studies in animals with damaged suprachiasmatic nuclei show fragmented, irregular sleep-wake patterns. Your sleep consciousness depends on this clock, which ensures you feel sleepy at appropriate times and alert when needed. Right now, that clock is signaling rest, releasing melatonin, preparing consciousness to cede control. Sleep may help clear emotions that would otherwise burden waking consciousness. Studies from 2024 using fMRI showed that emotional memories processed during REM sleep showed reduced amygdala reactivity when recalled the next day. The content remained, but the emotional sting diminished. This suggests sleep acts as emotional therapy, allowing you to remember difficult experiences without being overwhelmed by them. Without this processing, emotions accumulate, and consciousness becomes heavy with unprocessed feelings. Depression and anxiety disorders often involve sleep disturbances, possibly because disrupted sleep prevents this emotional clearing. Healthy sleep keeps consciousness light, able to face each day without carrying yesterday's emotional burden. Sleep heals what waking cannot process alone. Sleep positions affect dreams and sleep quality, influencing consciousness subtly. Sleeping on your back increases likelihood of sleep apnea and nightmares for some people. Sleeping on your stomach may reduce snoring but can cause neck strain. Sleeping on your side, particularly the left side, is often recommended for optimal breathing and circulation. Position affects physiology, which affects sleep quality, which affects consciousness. While you can't control position during deep sleep, you'll shift naturally. Starting in a comfortable position helps consciousness let go more easily. The body's comfort supports the mind's rest. As you settle now into your preferred position, your brain interprets this comfort as permission to proceed deeper into sleep. Dreams sometimes solve problems that stumped waking consciousness. The famous sleeping on it advice has empirical support. Research shows complex problems benefit from sleep, particularly REM sleep. One study gave participants anagrams before sleep. Those who reached REM solved more upon waking. Another study found that sleep helps with pattern recognition tasks that require seeing the big picture rather than focusing on details. Waking consciousness focuses narrowly. Sleeping consciousness broadens perspective. By releasing conscious control, you allow unconscious processes to explore solutions that conscious effort overlooked. Sometimes the best thing you can do with a difficult problem is stop trying. Trust your sleeping brain to work on it, and wake to find the answer waiting. Consciousness during sleep maintains your sense of self, even when you're not aware of it. You rarely dream of being someone else entirely. You might have different appearance, abilities, or circumstances, but the core, you persists. This continuity suggests that self-identity runs deeper than waking awareness. Even when the prefrontal cortex is offline and critical thinking is absent, the brain maintains a self-model. Research from 2024 showed that brain regions associated with self-referential thinking remain partially active even during deep sleep. You never fully lose yourself in sleep. the sense of I may dim, fragment, or transform into strange dream personas. But something of your identity persists beneath consciousness, ready to reconstruct itself upon waking. Sleep deprivation creates false memories more easily than normal sleep does. When sleep deprived, people are more likely to remember events that never happened or to confuse imagination with reality. This occurs because sleep deprivation impairs the hippocampus's ability to distinguish real from imagined experiences. Adequate sleep helps consciousness maintain an accurate relationship with reality. Without it, the boundary blurs. This is one reason eyewitness testimony is less reliable when witnesses are sleep deprived. Your memory of reality depends on sleep. Consciousness needs rest, not just to function, but to remain accurate. To know what actually happened versus what you imagined, feared, or dreamed. Truth itself requires sleep. The brain uses less oxygen during deep sleep than during waking consciousness. But REM sleep uses similar or even more oxygen than waking. This pattern reflects the different functions of sleep stages. Deep sleep is restorative, energy conserving, focused on repair. REM sleep is active, energy intensive, focused on processing. Consciousness during REM burns fuel at waking rates despite being asleep. This suggests dream consciousness is not passive rest but active work, perhaps as demanding as waking thought. Your brain doesn't rest during REM. It shifts tasks, using the same energy for different purposes. Sleep is not uniform unconsciousness, but a cycle of different consciousness states, each with distinct metabolic and psychological functions. Some research suggests that consciousness during deep sleep is not entirely absent but radically different. Philosopher Thomas Metzinger and neuroscientist Evan Thompson propose that deep sleep involves minimal phenomenal experience. Awareness exists, but is contentless. Without objects or thoughts, you're not aware of anything specific, but awareness itself persists. This is nearly impossible to study because waking someone erases the state you're trying to investigate. Meditation practitioners who've trained in witnessing consciousness report they can sometimes maintain awareness through deep sleep, experiencing consciousness without content, pure awareness without object. Most people never experience this. For them, deep sleep is a gap, a void, but perhaps consciousness is there, simply so minimal that memory can't capture it. Aging changes sleep consciousness. Older adults spend less time in deep sleep, experience more nighttime awakenings, and often report feeling less rested. This isn't just inconvenience. It reflects changes in the brain's ability to generate deep, restorative sleep. The suprachiasmatic nucleus weakens with age. Circadian rhythms become less robust, and sleep architecture fragments. Yet older adults need sleep as much as ever. The challenge is getting it. Understanding this helps reduce frustration. Difficulty sleeping in older age isn't personal failure, but biological change. Consciousness during sleep becomes lighter, more easily disrupted, more fragmented. Adaptation helps. Earlier bedtimes, strategic napping, optimized sleep environment. Sleep changes with age, but its importance never diminishes. Nightmares serve a purpose. Unpleasant as they are, they allow consciousness to confront fears in a safe context, processing anxiety that waking life hasn't resolved. Recurrent nightmares often relate to trauma or persistent stress. Treatment approaches like imagery rehearsal therapy help people consciously rewrite nightmare scripts while awake, which then changes the dreams. This shows consciousness can influence sleep consciousness. Waking mind affects sleeping mind. Nightmares aren't random torture, but attempts at processing. Your sleeping brain working through threats, trying to make sense of fear. If nightmares trouble you, consider what your sleeping consciousness is trying to resolve. Sometimes acknowledging the fear while awake reduces its power in sleep. Consciousness heals itself when given attention. Sleep consciousness across species reveals fascinating diversity. Dolphins sleep with one brain hemisphere at a time, maintaining consciousness in the other to breathe. Birds also show unihemispheric sleep during migration. Horses and elephants sleep standing up, entering REM only when lying down. Fruit flies exhibit sleep-like states despite having tiny nervous systems. Even single-celled organisms show rest-activity cycles. This suggests sleep consciousness evolved early and independently multiple times, indicating fundamental importance. What varies is the form. How much? When? What type? What remains constant is the need. All complex nervous systems require some form of rest state. Consciousness, it seems, cannot exist indefinitely without interruption. Sleep is universal because consciousness demands it. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your breath. Inhale. Exhale. Inhale. Exhale. A small cycle within the vast universe of cycles. Day becomes night, becomes day. Wake becomes sleep, becomes wake. Nothing is permanent. Everything flows in rhythm. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order. Like the moon silently orbiting Earth. Unhurried, unresisting, simply existing. We're almost there now. Consciousness doesn't go anywhere when you sleep. It transforms, shifts, becomes different forms of awareness suited to different purposes. The question assumes consciousness is a place you leave and return to. But consciousness is a process, not a location. When you sleep, the process changes. Sensory input decreases. Logic relaxes. Dreams emerge. Repairs begin. But the underlying neural activity continues. You never truly leave consciousness. You simply inhabit different versions of it. Deep sleep is minimal consciousness. Dreaming is vivid but disoriented consciousness. Waking is focused, reality-oriented consciousness. Each serves a purpose. None is more real than the others. Perhaps the better question is, what does consciousness become in sleep? It becomes restorative. It becomes integrative. It becomes creative. It releases control, allowing automatic processes to repair and reorganize. Consciousness steps aside, not because it's unnecessary, but because its presence would interfere. Some work requires absence of awareness. Healing happens best when you stop watching. Memory consolidation needs consciousness to stop actively encoding. Emotional processing needs conscious control to relax. Sleep is consciousness's gift to itself. A deliberate withdrawal to allow deeper work. By letting go, consciousness creates space for transformation it couldn't achieve while holding on. Sleep reveals that consciousness is not the same as selfhood. During deep sleep, the sense of I fades, yet biological processes continue maintaining your unique identity. Your cells still carry your DNA. Your immune system still recognizes self versus foreign. Your memories still exist, just inaccessible. The you that is body, history, and potential persists even when the you that is awareness disappears. This suggests selfhood has layers, some dependent on consciousness, others independent of it. You are more than your awareness. Sleep proves this every night. You exist even when not consciously existing. Being doesn't require constant awareness of being. In sleep, consciousness releases its grip on time, space, and identity. Dreams ignore physical laws. Time compresses or expands. You might be young again, or old, or both. You might be yourself, but also someone else. Logic doesn't constrain dream consciousness. This freedom suggests that waking consciousness imposes structure that isn't inherently necessary. The rules we follow while awake, causality, identity, time's direction, are useful for navigating reality, but consciousness itself doesn't require them. In sleep, consciousness shows its true nature: fluid, creative, unconstrained. The rigid waking self is just one possibility, not the only way awareness can exist. Sleep teaches acceptance. You cannot force sleep through will alone. You must surrender to it. Trying too hard keeps you awake. Sleep requires letting go of control, trusting your body to take over. This is difficult for people used to controlling everything, but sleep won't be commanded. It arrives when you stop resisting. This paradox appears elsewhere in life. Happiness comes when you stop chasing it. Creativity flows when you stop forcing it. Love deepens when you stop grasping. Consciousness often works best when you release conscious effort. Sleep is daily practice in surrender. In trusting processes beyond your control, sleep reminds us that consciousness is temporary, finite, intermittent. Every night, you practice the small release of awareness, the letting go that foreshadows final letting go. This might seem somber, but it's actually comforting. If you can release consciousness every night and reclaim it every morning, perhaps death is simply sleep without waking. Not annihilation, but transformation into a state beyond awareness. Many spiritual traditions teach this. Sleep is the dress rehearsal, showing that cessation of consciousness isn't pain or terror, but peace. The fear of death may partly be fear of losing awareness, but sleep shows loss of awareness can be gentle, even welcome. Dreams prove consciousness can create entire worlds from within. Everything you experience in dreams, every person, landscape, conversation, emotion, your brain generates. No external input needed. You are simultaneously the creator and audience of dream experiences. This raises profound questions. If consciousness can create rich, believable realities during sleep, how do you know waking reality isn't also constructed? Philosophers have asked this for millennia. You can't prove you're not dreaming right now. The distinction feels obvious. Waking has consistency, consequences, shared agreement. But the mechanics are similar. Brain activity creating experience. Sleep consciousness reveals the creative power underlying all awareness. Sleep shows that rest is productive, not lazy. Society often values constant activity, treating sleep as inconvenient necessity. But research proves sleep improves every aspect of functioning. Memory, creativity, emotional regulation, physical health, immune response, decision-making. Athletes who sleep well perform better. Students who sleep before exams score higher. Workers who rest make fewer errors. Sleep isn't time wasted, it's time invested. Consciousness during sleep accomplishes what waking consciousness cannot. Letting go is not giving up. Rest is not weakness. Sleep is work of a different kind. Invisible but essential. Without it, all waking efforts suffer. In sleep, the boundary between you and not you softens. Consciousness normally maintains clear distinction between self and other, inside and outside. But in dreams, this boundary blurs. You might experience being someone else, merge with objects, or lose track of where you end and the world begins. Some meditation traditions aim for this. Dissolution of boundaries. Experiencing unity with all things. Most people only experience this during sleep, unintentionally. It suggests that the separate, isolated self is a construct, useful while awake, but not fundamental. Consciousness can exist without sharp boundaries, flowing between self and world rather than standing apart from it. Sleep connects you to all humans across time. Every person who has ever lived slept. Every person alive now sleeps. Sleep is universal human experience. One of the few activities everyone shares regardless of culture, era, or circumstance. When you sleep, you join billions doing the same, experiencing the same surrender, the same mysterious transformation of consciousness. This universality is comforting. You're never alone in sleep. Across the world, people are closing their eyes, letting go, trusting the process. Sleep is humanity's shared ritual, older than civilization, connecting you to ancestors, contemporaries, and future generations yet born. The question, where does consciousness go, assumes it's a thing that travels. But consciousness isn't an object or substance. It's a process, an activity of the brain. When you sleep, the activity changes, but nothing goes anywhere. It's like asking where music goes when you stop playing. Music doesn't go anywhere. The process of creating it stops. Consciousness is similar. During sleep, the brain continues functioning, but stops creating waking-type awareness. Different brain regions activate. Different networks communicate. Different processes run. Consciousness doesn't depart and return. The brain shifts modes, and we call those modes by different names. Some describe sleep as returning to pure being without doing. Waking consciousness is always doing, perceiving, thinking, planning, reacting. It's exhausting. Sleep allows cessation of doing, resting in simple being. Your body continues existing. Cells continue living. Heart continues beating. But you, the conscious observer, stop striving. This rest is profound. Many spiritual practices try to achieve it while awake. Meditation, prayer, contemplative practices. They seek to stop the constant doing and simply be. Sleep gives this freely every night. You don't have to earn it or practice it. Sleep is grace, offering rest without conditions. Sleep reveals consciousness is relationship, not isolation. When awake, you feel separate, bounded by your skin, alone in your skull. But sleep research shows your consciousness affects and is affected by others. Sleeping next to a partner synchronizes sleep cycles. Caregivers wake to babies' sounds. Your stress disrupts loved ones' sleep. Consciousness, even in sleep, remains embedded in social networks. You're never truly alone, never fully separate. Sleep is social, relational, interconnected. When you sleep, your quietness affects the quiet of those near you. Peace spreads, anxiety spreads. You share sleep space with others, influencing and being influenced, even in apparent solitude. The mystery of consciousness deepens in sleep. Science explains much. Brain regions, neurotransmitters, sleep stages, functions. But the fundamental question remains: why is there subjective experience at all? Why does brain activity feel like something from the inside? Sleep makes this mystery more mysterious. If consciousness is just brain activity, why does it seem to disappear in deep sleep when the brain is still active? Why do dreams feel real? What exactly is awareness when it has no content? No object, just pure being? Science maps the mechanisms, but cannot fully explain the experience. Some mysteries endure even as knowledge grows. Sleep teaches humility. No matter how accomplished you are, you still need sleep. You cannot will yourself to stay awake indefinitely. You cannot think your way out of needing rest. Consciousness depends on biological processes beyond your control. This limitation is humbling. It reminds you that you're not mind alone, but embodied. Biological, mortal, even the most disciplined consciousness eventually succumbs to sleep. Even the brightest awareness must regularly dim. This humility is healthy. It connects you to your animal nature, to the body's needs, to limitations that make you human rather than machine. Perhaps consciousness during sleep is preparation for consciousness after death. Many religious and philosophical traditions suggest this. Sleep is temporary. Death is permanent. Sleep consciousness changes. Death consciousness, if it exists, is unknown. But the daily practice of releasing awareness, letting go of control, surrendering to processes beyond understanding, this might prepare you for the ultimate surrender. If you can face sleep's small release every night with trust rather than fear, perhaps facing actual death becomes easier. Sleep teaches that letting go can be peaceful. That cessation of awareness isn't suffering. This lesson might be sleep's deepest gift. Sleep reveals the rhythm underlying existence. Not just sleep-wake cycles, but all cycles. Breath, heartbeat, seasons, day and night, birth and death. Everything pulses between complementary states. Activity and rest, expansion and contraction, chaos and order, consciousness and unconsciousness. These rhythms aren't opposites fighting, but partners dancing. Each needs the other to exist. You cannot have constant consciousness without rest. You cannot appreciate waking without knowing sleep. The rhythm is the reality, not the individual states. Sleep shows you're part of this universal pulsing, this cosmic rhythm that moves through all things. In sleep, you experience the universe experiencing itself. Consciousness is the universe's way of knowing itself. When you look at stars, the universe looks at itself. When you sleep, the universe rests itself. You're not separate from nature, observing it from outside. You are nature, aware. Sleep returns you to the source, dissolving the illusion of separation. During deep sleep, boundaries fade. The distinction between you and everything else softens. Some describe this as touching the infinite, the eternal, the ground of being. Most don't remember it, but perhaps consciousness during sleep connects you to something larger, even if waking mind forgets. Sleep shows that consciousness is cyclical, not linear. Waking culture emphasizes progress, forward movement, accumulation, but sleep resets everything. Each night, you return to zero, releasing the day. Each morning, you start fresh. This cycle prevents accumulation of exhaustion, emotion, mental clutter. Without sleep's reset, consciousness would degrade under accumulated weight. The cycle is cleansing, renewing. Perhaps life itself is cyclical in ways we don't see. Perhaps consciousness continues beyond death, cycling into new forms, eternally resetting, eternally beginning again. Sleep might be training for this larger cycle, teaching the rhythm that governs all existence. Sleep is where consciousness meets mystery. Science illuminates much, but the subjective experience of sleeping and dreaming remains deeply personal, private, ineffable. No one can truly know what your dreams feel like, what your sleep experience is, even with identical brain activity. Your inner experience is yours alone. This privacy is consciousness's essence. The fact that experience exists at all, that it's like something to be you. Sleep preserves this mystery. In a world increasingly explained, measured, and mapped, sleep remains stubbornly subjective, resistant to full explanation. The mystery is not ignorance, but wonder. The appropriate response to consciousness itself. Perhaps consciousness never leaves because it never was a thing that could leave. Perhaps consciousness is the space in which experience occurs, not the experience itself. Thoughts, sensations, emotions come and go, but awareness itself remains constant, even in sleep. Something is aware of sleeping, even if that awareness has no content. This is a radical idea from contemplative traditions. Consciousness is primary, unchanging, eternal. Forms arise within it. Waking forms, dreaming forms, deep sleep forms. But consciousness itself never changes, never arrives, never departs. If true, the question, where does consciousness go, is meaningless. Consciousness is always here. Only forms change. Sleep is surrender. Every night you practice letting go of control, trusting unknown processes, accepting vulnerability. You close your eyes not knowing what will happen. You might dream, might not. You might sleep peacefully or restlessly. You cannot control it. You can only let it happen. This surrender is profound spiritual practice, whether you realize it or not. Releasing the need to manage everything, trusting that rest will come, accepting that consciousness will return without your effort. This is faith. Sleep teaches faith in life's rhythms, in the body's wisdom, in processes that don't require your conscious participation. Every night, you practice trust. When you sleep, you participate in the ancient rhythm that predates humanity. Before consciousness evolved, before brains, before animals, life exhibited rest activity cycles. Plants close at night, open at dawn. Bacteria show circadian rhythms. The earth itself rotates, creating day and night. Sleep plugs you into this ancient pattern, billions of years old. You're not creating sleep. You're joining it, participating in the rhythm that shaped life from the beginning. Consciousness arose within this rhythm and depends on it. When you sleep, you honor something older than yourself, something fundamental to existence itself. You become part of the pattern that makes life possible. Sleep reveals that doing nothing is doing something. The modern world glorifies action, productivity, achievement. But sleep shows that rest is productive, that stillness is active, that letting go accomplishes what effort cannot. During sleep, your brain works harder than during many waking activities. Consciousness withdraws, not because work is done, but because different work begins. Healing, integration, consolidation, clearing. These require absence of awareness. The lesson extends beyond sleep. Sometimes the wisest action is inaction. Sometimes the best intervention is stepping back. Sometimes consciousness serves best by getting out of its own way. So, where does consciousness go when you sleep? Nowhere. Everywhere. Inward. Into transformation. Into renewal. Into mystery. It doesn't go. It becomes. It doesn't leave. It shifts. The question assumes separation between consciousness and sleep. But they're partners, not opposites. Sleep is consciousness in different form, serving different purposes. When you sleep, awareness doesn't vanish. It dissolves into repair, reorganization, and renewal. It spreads through your body as healing processes activate. It sinks into the foundations of being, touching something wordless and deep. Tomorrow, consciousness returns, refreshed, carrying gifts from the place beyond awareness. And the cycle continues, eternal, necessary, perfect. Tonight, as consciousness fades, know that you're not losing anything. You're transforming. The awareness reading these words will become sleep's quiet work, dreams creativity, rest's restoration. Nothing is lost. Everything returns. Sleep is not death but renewal, not ending but transformation, not absence but presence in different form. You are safe in this surrender. Consciousness doesn't leave you. It becomes something else, something necessary, something that will return you to waking more whole than you entered sleep. Let go. Trust the process. Allow consciousness to do what only sleep permits. You are held by rhythms older than thought, deeper than words, gentle as breath. Rest now. And so, our quiet journey through consciousness and sleep comes to a gentle close. We've traveled from the bright alertness of waking awareness to the mysterious transformations that happen when consciousness surrenders to sleep. discovering along the way that awareness never truly disappears, only changes form. From the thalamus's gateway opening and closing, to dreams creating entire worlds from neural activity, to the glymphatic system clearing away the day's waste while you rest. We've glimpsed how consciousness is both fragile and resilient, temporary and eternal, individual and universal. Sleep reminds us that letting go is necessary, that transformation requires surrender, that some of life's deepest work happens when we stop trying. Much of the healing, the integration, the reorganization happens in darkness, in quiet, in the space where consciousness releases control. Sleep teaches patience, humility, trust. Without these nightly journeys into altered awareness, we would lose ourselves to exhaustion, confusion, accumulated pain. By pausing to notice, we glimpse the extraordinary gift that sleep offers, the chance to become new again, to wake tomorrow carrying the rest we didn't know we needed until it arrived. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about the unity of all consciousness, yours, mine, everyone listening, all awareness, everywhere. Perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Think about consciousness itself, the fact that experience exists at all, that it's like something to be you, to be aware, to witness this moment dissolving into sleep. Let your entire being dissolve into the ocean of awareness, into dreamless rest, into the space before thought, the silence before words. Prepare for deep sleep. No boundaries left between you and rest, only peace. Only the gentle fading of all that was into all that will be. When morning comes, if this thoughtful exploration of the mind made you feel less alone, whisper it forward to someone awake tonight, searching for answers, searching for peace. It may bring comfort to one more wandering consciousness, one more sleepy soul finding their way to rest. But there's no need to do anything now, nothing at all. You've traveled far tonight, through the landscape of consciousness itself, exploring questions most people never pause to consider. You can allow these thoughts about awareness and sleep to fade now, like morning mist dissolving in sunlight, leaving only the gentle calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself is gently pulling you down into the mattress, into the pillows, into the earth that holds you. If sleep comes, let it carry you like consciousness returning home, smoothly, inevitably, into a realm where questions dissolve and only being remains. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, consciousness will still be there. The mystery of awareness will still be worth exploring. But tonight belongs to stillness, to surrender, to the gentle transformation that only sleep provides. Rest well, dear traveler of consciousness, and remember, you are not your awareness alone. You are the space in which awareness happens, the rhythm that cycles between knowing and unknowing, the eternal witness to every moment's rising and falling. Fall asleep to gentle psychology. Relax your mind and drift into deep sleep. Dream deeper with bedtime science. Good night.